angle between two lines. So to know about this topic, angle between two lines, you need to know dot product between two vectors, and second, its application, angle between two vectors. So first let me take one example of dot product between two vectors. So I'll consider two vectors. For example, one vector is A. You can write in column method. For example, 2, 1 and 3 are the components, and vector B is -1, 2, 1, like that. Okay. Now the dot product between two vectors. Basic definition of dot product is AB times cos theta. Theta is angle between two vectors. A and B are magnitude. So A is magnitude of vector A and B is magnitude of vector B. So if you know their magnitudes and angle between them, so dot product you can find out from here. But if you have components like what we have right now here, component of A and components of B, means in the form of ijk, ijk. So in this case, dot product can be determined using very simple method, like I component with I, so 2 times -1 plus y component with y, means j with j, so 1 times 2 plus 3 times 1. So if you simplify this, -2 plus 2 and plus 3, so you will get your answer 3. So 3 is the dot product between two vectors A and B. So 3 is a magnitude only. It will not have any direction, therefore it is always a scalar number. So dot product between two vectors is always a scalar number. Okay. So remember, if you have components of A and B, then this is the method how to figure out. If you have magnitude and angle, then you should use this method. Now why we are looking at this example or case, A dot B is AB cos theta, because I want that you please try to understand what we are trying to do with dot product, angle between two vectors. So when we say angle between two vectors, so that therefore we will use this portion, A dot B. So guys, if theta is the angle between two vectors, so that can be written as cos theta is A dot B over their magnitude. So for example, if you continue with this case, I have A dot B, which is 3 over magnitude of A, you know magnitude of A, so 2 square is 4 plus 1 square is 1 and 3 square is 9. Okay, and times magnitude of second vector, 1 plus 4 and plus 1. So finally we will get 3 over 9 and 4, 13 and square root 14 times square root of 6. So this is your cos theta. So angle theta would be cos inverse 3 over square root of 80. 14 times 6 is 84. So you can use calculator to find out what is cos theta in this case. So if you understand this cos theta and dot product, that's the same concept we are going to use to determine angle between two lines. So L1 and L2 are two lines, and theta is acute angle between them. So that's what we are going to use, the concept cos theta. So I will highlight it again. Next slide, let's see. So you can see cos theta is B1 and into B2. So you can understand what B1 and B2, because in two lines we take their parallel vectors, their direction vectors. So B1 and B2 are two vectors, and B1, B2 denominator is their magnitude. So dot product and divided by their magnitude. And make sure you take modulus, because we are talking about that acute angle between two lines. Okay, so cos theta should be always positive. So in this case we will determine acute angle only. Now there are some properties of angles. So if for example there are two vectors r1 and r2 are parallel, it means they will be scalar multiple of each other. Okay, so they are parallel. It means there is the angle between them is 0 degree. Okay, or 180 degree something. So R1 and R2 are perpendicular. It means the dot product would be 0, because if you see 90 degree, theta is 90 degree. So if theta is 90 degree, so cosine of 90 is 0. Therefore dot product should be 0, because denominator cannot be 0. So only numerator would be 0. So we'll see in next example. Here you can see find the angle between two lines. These lines are written in parametric form. We can convert them in other format. So L1 can be written as x, y, z equals to, what is the point through which it is passing through? 2 and minus 1. Sorry, it does not have z, so I will just take x and y. Okay. I will take only x and y. So xy equals to 2 and minus 1 plus t times negative 3 and 1. Okay, so similarly you have L2. So L2 is 1 and minus 4 are points, or xy equals to 1 and minus 4 plus s. There is another parameter. Okay, so 2 and 3. Now you need to understand, when you decide angle between two lines, it means we are talking about angle between two parallel vectors. So these are two parallel vectors. So my first vector is negative 3, 1, and my B2 vector is 2, 3 from here. So using cos theta as we did in the last case, so dot product, so negative 3 times 2 plus 3 times 1. Make sure you take modulus, because we're talking about acute angles, divided by their magnitude. So 9 plus 1 is 10, and 4 plus 9, 13. Okay, so in this case you will get your answer as negative 6 plus 3, 3 over square root of 130. Then you take cos inverse, you can get easily the angle. Now let's take one more example here. So here is a question: find angle between two lines, L1 line and L2. So if you see carefully, the representation of lines, it's in vector equation. In vector equation, as you remember, 8, 9 and 10 in this case is the fixed point through which your line is passing, and in this case 15, 29 and 5. They're not playing any role for determining the angle. Okay, so just leave them. We will focus on B1 vector and B2 vector, because B1 vector is parallel to my line, B2 vector is parallel to my second line. So as you know, cos theta is B1 dot B2 divided by the product of their magnitude. So we will figure out B1 dot B2. So B1 dot B2 means I component of first with I component of second, J component of first and J component of second. Similarly with the third one also. So 3 times 3 is 9, minus 16 times 8 minus 28, 7 times minus 5 35, and divided by their magnitude. I have calculated separately. This is the magnitude of B1 vector, and this is the magnitude of second vector B2. If you simplify, you will get cos theta equals to this, and after that you can just do shift cos or cos inverse, whatever language you use. I will use modulus because the value is negative. So if you enter in calculator, don't enter negative values, you will get obtuse angle otherwise. So just enter these two values in a positive way and you'll get the angle. Now we have B part also. In B part, the line L3 and line L1, they are perpendicular to each other, and L3 direction vectors are already given. For L1 we have already. So B1 and from L3 I got, maybe you can say B2. This is my B2 vector. So they are perpendicular to each other, so the angle between them would be 90 degree. So when the angle is 90 degree, cos 90 is 0. And what is cos theta? Means the concept of angle, b1 dot b2 divided by their product of magnitude equals to 0. So this becomes actually a rational number, okay, fraction, numerator and denominator. So in this case, numerator would be 0, denominator cannot be 0, and it's of course the magnitude. So b1 dot b2 is 0, b1 dot b2. So dot product as usual, you can figure out 3 times 0 is 0, negative 16 into negative 3 is plus positive 48, 7 times x, 7x equals to 0. Here we can calculate x easily, and x equals to 48 over negative 7. Thank you.